Namaste everyone. In this video we are going to continue our previous problem. If you have not seen the previous problem, we have solved the velocity for these points, point B, E, C and D. The link to that particular video I'll leave in the description below. So if you have not watched it already, you can go back and watch it before continuing with this one. So in this video we are going to find the velocities of points which are not directly on the links. So we have the D bit and the E bit with such a case. So we have a point F which is on link BC but not exactly on the line joining them, and we have been given the lengths BF and CF. Let us first go ahead and mark the point F. So we've been told we have been given the values of BF and CF, and we have been told BCF is read clockwise. So when you go to B and C, we have to go clockwise in order to find F. So F is going to be somewhere in here. So let's go ahead and mark that point. So we know the distance from B is 45. So I'm going to go draw a circle from this of length 45, and from this point, from point C, we have to draw another arc of length 30. So let me go ahead and take this scale over here, and I'm going to draw an arc. In fact, I'm drawing the complete circle. You need not draw the complete circle when you're using the drawing sheet. What we just need is the intersection here. So that's it. So these two arcs we need. So this arc is at a distance of 45 from B, and this arc is at a distance of 30 from B. And the intersection point, it satisfies both the conditions that we are interested in. So this point here is our point F. So now we need to find this the velocity of this point F here with this particular diagram. So we already have the velocity diagram, and we already have the length BC, and we need to find the point F here using similar triangles approach, and we need to maintain the clockwise motion, clockwise direction in which the points appear. So B, C, F, they appear in clockwise direction. So here as well, when you go for B to C, we have to go clockwise in order to get the last point F. So F is going to be somewhere outside of this triangle. So I'm just going to move this aside a little to make space here, and we need to just build the same diagram over here. Okay, so we'll be using the length ratios here in order to build a similar triangle over here. We already know the length BC, and that is 66. We already know the length BF, and that is 45. Now we need to use the comparison here for the velocity diagram. So we already know, we also know we have built the length of small BC. Now let us see how much it comes out to be from this point to the point C. We see that it is 3.4 something. Let's take that here. So 3.4 or 34 mm, and similarly we have to find BF. So we just need to multiply these two and divide by this. So doing that, we are getting a length 23 point, no, we can just ignore it. So we can just take 23 mm as the length for BF. So and similarly we'll have to find actually CF as well. So CF length, so capital CF. Okay, so sorry, we have to actually take CF the same way we took BF here. So small CF we'll have to actually find using the length capital CF. So capital CF, we know that to be 30, and accordingly we need to find the smaller CF. So once again we're going to use that same method. We have to multiply these two, divide by this. Let's go ahead and do that. So 34 into 30 divided by 66. So this is what we're getting, 15.5. So let's go ahead and use 15.5 for CF. So we have to mark an arc from B, and we have to mark an arc from C, and wherever they're intersecting, that's what is going to give us the point F, and we can join the point F. So let's go ahead and do that. So B to F 23. Let's go ahead use this scale. Okay, so I'm going to use this scale over here. So from B, I need to draw an arc of 23. 23, no? And then from C, I need to draw an arc of length. From C, it's 15.5. So let's just get point in between these two. So these two are the arcs, and we need the intersection point of that. So let's just join these points and remove these arcs. I don't need those arcs. And this is going to provide us with the point F. So now that we have got the point F, in order to find the velocity of F, we just need to join this point here with the F, and this line is going to provide us with the velocity of F. Let's go ahead and measure it. I'm going to take the scale right here and see what is the measurement. So we can see that it is 5.05, so 50.5 is the velocity of E. So going back here, we'll have to use the same velocity ratio here that we have used earlier. So we want to find the velocity of F, and we got the measurement here as 50.5 in mm. So we need to convert this back into meters per second. So what we need to do, we need to just divide it by 100. So we get 0.505 meters per second. So this is the velocity of F. So, and this is the answer to our T bit. This is the answer to our T bit. Same way, we have been also asked to create another point, and that point is G, and here the details of the G point has been given. So there's a point G on CD such that CG is 24 and DG is 44. So we once again need to find that other triangle. Let's first go ahead and create that point G over here in the position diagram. We in fact don't need this velocity at all, so I'm just going to remove it. And G, where is it going to appear? It's going to appear such that DCG is clockwise. So DC and G has to come clockwise. That means it's going to be outside. So let's again take the scale. Okay, just going to avoid rotation. Just going to take the scale here, and I need to draw an arc of length. How much? From D? From D, it's going to be 44. So let's go ahead and 44. Then I have to make another arc. We got to place this correctly, and this time the arc length has got to be 24 from C. So let's go ahead and draw that arc. So this has got to be 24, and we need the intersection point. So let me just mark this. Let me just join these lines and delete these two arcs, and this point that we get is the point G. So now that we have got the G point in the position diagram, the same we need to attain here in the velocity diagram. So CDG has got to be similar to C, D and G. Fine. So I'm just going to take these two, copy them in order to just going to avoid the calculations over here, and I'm going to use the align command here, and this is going to remain here, whereas this point is going to appear here. So that's it. Do you want to scale the objects? Yes. So now you can see that by various calculations that we did, the same calculations were okay. So they were not actually done correctly. We had to move this, so this was placed at D, so I have to move this point over to D. And now let me go for align command, and okay, align command. This point is going to remain at the same place. This point, however, is going to appear here at C. And just press enter, scale the objects. Okay, and so we can see that this graph has been created. So let me place this point. This point is going to be G. And you can see that DCG is clockwise here in the position diagram, and DCG is clockwise here as well in the velocity diagram. So, and one of the lines is already joined from G to the fixed point D, and this here is going to be the velocity of the point G with respect to the fixed point D. So hope you have understood this particular video, and in the next one we are going to take care of all the angular velocities. If you have any doubts with respect to this particular video, you can let me know in the comments and I'll try to solve it out. Okay, then